The last type of asymptote that we have are slant asymptotes, and these only occur in one specific case, and that specific case is when the power on the top, so the degree of the numerator, is exactly one larger than the degree of the denominator. Okay, so in this case, I've got a degree of 3 on the top and a degree of 2 on the bottom. That means I'm going to have a slant asymptote. And these asymptotes, again, apply to what's happening as our x values get very big positive or very big negative. So in order to find what these slant asymptotes are, we're going to use our old friend long division, polynomial long division. You could also use synthetic if you prefer synthetic, but again, in this case, synthetic wouldn't work because I don't have a degree of 1. Okay, and that's the only time you can use synthetic division. So if you are able to use synthetic division, you can use it, but most of the time it's not going to work, so you have to use polynomial long division. And I'll kind of show you how this works. So what I'm going to do is I'm going to divide this out just to get a different representation of what this function really is, because it's the top divided by the bottom. So if I can actually do that operation, it'll give me a different representation of the same function. So let me do my division here. I have 3x cubed minus 4x squared plus x minus 1. I'm dividing by x squared plus 3. So I need to match the 3. X cubed, so I'm going to multiply by 3x. That'll give me 3x cubed plus 9x. Change my signs. Add these up. This cancels. This turns into negative 13x squared. So I need to multiply by negative 13. Okay, I'm going to carry the x down. And then I get negative 13x squared. And this would be minus 39. Which doesn't really line up with the x, but it does line up with the negative 1. So we'll combine these, change my signs. This cancels, my x comes down, and then I've got plus 38. Now at this point, I can't get this to match the x, so this is my remainder. Okay, I'm going to have x plus 38 over x squared plus 3. So at this point, this answer here is the exact same thing as this, okay, because it's the answer I get when I actually do the division. And I want to know what's happening to this as x gets very large, okay? As x gets very large, I'm going to have a large number here, minus 13, and then this term here, if I have very large x's, it's kind of like having a separate rational function inside ours, where I have a smaller degree on the top than I do on the bottom. If you remember, this goes to 0 as x gets large. So we're only looking at what happens as our function goes towards large numbers, so I can treat that as a 0. And then what I have is this function that I'm left with, y equals 3x minus 13, is the equation of my slant asymptote. So if I were to graph this, I'd want to graph this line and use that as my slant asymptote. And the way we'll do that is just like graphing a line. Okay, so I need to go down to negative 13. So it's 10, 11, 12, 13. That'd be my y-intercept. And then we're going to go up 3 over 1, up 3 over 1. Okay, and just keep doing that. I want to keep going so keep following your slope till you get a very nice straight line that you can connect, because you don't know where the rest of your graph is going to be in relation to this. But that's going to be my slant asymptote. So what my graph is going to do, and you're allowed to cross slant asymptotes kind of in this area here, but as you get towards the bigger x values, either positive or negative, it's going to approach this slanted line here. So let me just put it in as a dotted line. Okay, this is my slant asymptote, and my graph will do something, I'm not going to go through the specifics yet, but maybe it's, maybe I've got another asymptote here. Let's see. I won't have any asymptotes on the bottom, so there's no vertical asymptotes. And if I have a slant, I don't have a horizontal. So my end behavior, if I put a large negative number in here, it's going to go towards negative infinity. It's going to follow. So maybe there's some, weird curves down here. But as I go down, this line is going to get closer and closer to my dotted line. Okay, so it's going to keep getting closer and closer to that. And maybe this comes, and then it starts to follow this slanted asymptote up. Okay. So I'll take a quick break here and actually graph this so we can see what's really happening. Okay, so here I've graphed our slant asymptote, and I've graphed the actual function. And if you watch, as we get larger and larger x values, it's going to get closer and closer to that slant asymptote. In fact, if I zoom way out here, it looks like it's pretty much the same line. Okay, but there's a little bit of curvature kind of in these smaller x values here. Okay, and as I go negative, okay, it's getting closer and closer to that slant asymptote. Okay, so that's how you find slant asymptotes, and now you can find all the different types of asymptotes. Just remember that this only occurs when the degree of the numerator is exactly one larger than the degree of the denominator.